Okay. So, Mal Technology, we're an ANSYS channel partner. Um, uh, we use world-class engineering software tools like ANSYS, combined with our broad knowledge and expertise. We help our clients compete in today's marketplace and produce reliable and cost-effective products. So, being a channel partner, we do consulting and we are ANSYS software distributor. We've been in the business for nearly 40 years, and we have a long history with ANSYS. We started as a consulting arm for Swanson Analysis Systems, which was founded by Dr. John Swanson, which has a long history with ANSYS, and we've been a channel partner since '85, quite a while, and that's our website, mallet.com. Like I said, Fridays happen at 11 a.m. every Friday. Um, and if you have any suggestions for future webinars, we're happy to adjust our topics to your interests. Please contact Boz. And that's it for the intro slides. Let's get started. So I'm just going to open up the software here. So one thing to note about Discovery Live is that it does take some computing power. You need to have a fairly robust graphics card to use it. You need a graphics card with at least 4 gigabytes of video RAM. And that is because Discovery Live uses the video card processing to run this thing. And as you'll see shortly, it's very impressive. It generates results in real time. But we'll just jump right into it. Here, let's do a simple structural problem. So this is what you see when you open it up. You'll see these sample models that of which some we'll refer to a couple today. You can choose these different physics to simulate. And if you have any questions, right when you open it up, you can easily access the help or the tutorials or the forum. But we'll just start with a structural problem. I'll open up this bracket geometry. So after you load your geometry, you'll see this. You'll notice that a lot of this will be reminiscent of the space claim interface, if you're familiar with that, or the AIM interface, of which it's really related. It's easy to navigate. A lot of the manipulation tools are similar to space claim or mechanical. The only difference that I found that frustrates me a little bit is that you can hold down Control and the middle mouse button to zoom in and out. But otherwise, it should be very familiar to ANSYS or space claim users. So we have our bracket. Let's add some simple supports to it, run our analysis. We'll select these faces and generate a support on them. So you'll notice that after selecting the faces, you come up with this context box over here. And it's suggesting that I add a support, first of all, but you can hit this drop-down menu and select these other things related to mechanical physics. But since we want a support, fixed support, we'll just add that. All right, so it's fixed. And you can see that over in the tree over here, have this fixed support. And then we'll turn it around and we'll add a force to it. And I haven't done anything yet, but you'll notice that there's another menu at the bottom of the page. I'll just have that pull out. And it used to say play. Now it is playing. The solver's active. As soon as I entered the force, it generated a solution. It's this von Mises stress plot over here. And it does this all very quickly, instantaneously almost. Uh, so it generated this. It'll generate just as fast if I change the number. You can see the von Mises plot numbers. The contour bands, they change slightly. It generates a really quick general solution, and then it refines it. Um, and we can take a look at a few other values down here. And if you don't want to see stress, you can see, well, let's see. Let's do deformation, maximum deformation over here. You can do it by component, just like you would in mechanical, X, Y, or Z. We can look at the surface. We can look at an ISO surface. It's really easy. You can scroll through. Of course, this isn't very helpful. You low displacement at the back, high displacement at the front. Another thing to keep in mind here, I'll change that back to viewing the results on the surface. Another thing to be aware of is this speed versus fidelity. So you can change these results really quickly. However, you can up the fidelity, and it'll take a little longer to solve, just a few seconds as opposed to a fraction of a second. But it'll increase the accuracy of the solution. Let's see, and it's very easy to navigate and change these values. We had this force attached in the y direction. Let's change it in the negative z direction. See it there. Change that to 0. It just generates a solution just in the blink of an eye. One thing you can do is, let's see. Is you can track a particular output value as you change these things. So let's see, I want to choose the maximum stress. I want to see how that changes as we change these values. So you can see right now, the maximum stress is 7.8 e to the 4 kilopascals. And let's see what happens to that stress as I show you another one of these features. So another one of these features is you can edit the geometry while you're in here. So I want to see what happens. Well, let's choose a better one as we pull this face. So we'll make this a little wider. That should add some stiffness. Let's see what happens. So I pull it out in the 16 millimeters. It generates another solution. And you can see it decreased the maximum stress from 7.8 e to the 4 kilopascals to 7 e to the 4 kilopascals. You can also view animations. This is all your visualization stuff down here. You can choose the speed or how fast it goes, the scale. It's all pretty intuitive. If you hit true deformation, it'll show how much it actually is deforming. It doesn't exaggerate it. It's just barely visible here, as you might expect. It's easy to flip through materials. And in this way, Discovery Live is really, really valuable as a design tool. They've nailed the concept, but and they're adding more features all the time. Right now, in comparison to say AIM, it doesn't have as many features, but it's for its intended purpose to be used as discovering different designs. It's very, very effective. So this was just a basic static structural let's explore a different kind of physics. So I'm going to close this, open a new session. Should take just another moment. All right, here let's do internal fluid flow, and we'll look at, where is it? Flow through these pipes here. And so it'll try to guide you through this analysis. You can see at the top left, it's giving us a prompt, select inlet faces. So in the structural one, it had something similar. I didn't point it out before, but it's helpful. So select inlet faces, it's easy. I just mouse over it. That looks like an inlet. I'll click it. Oh, that's an outlet. Oh, but if you look at the top left, it says we can hit Control to switch it over. And then we can select an outlet face over here. We can also hit Shift, like it says, to create a capping face. However, this is an outlet face. And you can see it automatically just starts to generate a solution. I can hit pause to have it stop doing that if I want to make some changes before it generates it, but since it generates it so fast, why not have it play? It automatically chose air and these initial flow velocities of half a meter a second. However, that's easy to change. We can make this water. We can change this upper velocity to 1 meter a second, and that'll change this. This is let's look at the solution we're plotting right now. It's the velocity. You can show where the minimum and the maximum are. And you can see this is changing over time. It'll keep going. This is not in the case of this flow, it's not a equilibrium solution. This is a solution over time. Let's see, we can also view it in a cut plane. Click on this button here. It's very helpful. It's easy to manipulate the cut plane. Click on it. I can, just like in space plane, you see the same thing. This will be familiar. You can drag it. You can turn it. Turn it off. Instead of that, let's say we want to see streamlines. So yeah, we can see all the streamlines here. In addition, we can pick a particular spot where we want the streamline to start. So you can see how that goes. If we wanted to see the streamlines from just one position, we could do that. In addition, we can view these particles similar to the streamlines. So yeah, very powerful visualization tool. Here's another thing. You can do multiple visualizations at once. This is show you kind of a combination of the two. It shows you like where these little eddies are. Here, I'll zoom in. Pretty cool. It's really easy to set up and do once you have your geometry to import. Let's see. um, I'll bring up one more physics to share with you guys. It'll be a thermal problem. Close this. Um, some of the features that they're going to add right now, ANSYS or ANSYS Discovery Live can only do single physics, but I know they're adding a multi-physics option, so it'll encompass those features that AIM has. Also, a topology optimization. So it's going to get more and more powerful in the very, very near future. Let's see. Open up the cooling assembly. It's a space claim document. Um, so the space claim document had um, some things already specified in it. Um, so as we open this up, we can see we have these two look like microprocessors in this heatsink. It's already specified materials. It's the heat pipe material. It's a solid that runs through both of them. The ambient temperature. This was included in the this enclosure geometry was included. The convection coefficient, which will transfer heat between the ambient enclosure and the all the bodies here, and the heat flow generated here. So it kind of started out with everything specified, but it's simple enough to add things. Just remember, you click on it, open up your context menu, you can select any of the appropriate boundary conditions or loads. So all we need to do, since everything's specified, we can just hit play. And you can see it's generated a plot of temperatures, if you're not sure what you're plotting. It's temperatures. And I'll plot it on the surface. Similar to before, we can see the heat through the surface. It's maximum right where the heat's being generated naturally. And we see minimum, maximum. We might want to investigate how things change. This is really where the power of Discovery Live comes in. So right now, let's see, what might we want to change? So maybe we want to change our heatsink geometry, see how that'll affect the maximum temperature. So maximum temperature and volume, we have our parameter study over here. Heatsink to temperature. I'm going to delete these heatsink temperatures so we can just focus on the maximum temperature and the volume. It's 76 degrees Celsius right now. Let's see what happens if we want to pull these up. Oops. And let's do it simpler. Select it this way. So we dragged it, made it pretty tall. And see our maximum temperature and the volume has changed. Here, let's increase the fidelity of the solution. There, that's more what we expect. We expected it to decrease. So that's definitely something to be aware of, how high your fidelity is. On simpler solutions, you can get away with a really high fidelity and it'll run just as instantaneously. So in addition to like just pulling or moving, fill, combine, just your standard geometry editing things. Um, you can change these faces in any kind of way. Let's see, um, draft, sweep. It has everything that your geometry editor has, in addition to being able to explore all these physics. And it's really great for exploring new options in your design that way. I believe I have covered all the particular aspects of ANSYS Discovery Live that I intended to show you. So based on what you saw, I certainly didn't go over everything. If you guys have any questions, I would be more than happy to answer them. You can type them in the chat or just feel free to ask them out loud. Well, if on model size, I believe the limitation is only as big as your computer can handle. So the complexity is limited by the features available in Discovery Live right now. However, I think as far as sheer number of certain aspects, as far as bodies or complexity of geometry, I don't believe that is limited. Just the kinds of physics you can use at the moment. But like I said, they're always expanding on that. Did you have a particular aspect of the complexity of the simulation that you're interested in? I can maybe speak to that. Sure, I can create another boundary condition. So just as an example, right now we're in the geometry portion of the menu up here. If we click down here to setup, we can click on any of these faces or triple click to select the geometry. And whenever you do that, it comes up with this context menu up here. It'll have all your boundary conditions. Since I selected a body too, I could also change the material, but you can select anything related to bodies at temperature, heat flow, or flux. You can insulate a face. This is all particular to this thermal analysis. See, yep. And whenever you do that, let's see, convection, and choose the film coefficient and the ambient temperature, just like you might expect. Choose something crazy. And whenever you do that, you can come down here and see the things you've chosen and edit them down in the tree. So that'll keep track of everything that you put in. No problem. Yeah, it's pretty intuitive. You know, if you want to change something, just click on it. Yes, you can edit the material properties or add new material properties. So if you right-click on a material, you can open the material library. It'll have some of these here, but you can always add a new one. So it'll import any geometry file that SpaceClaim can import. Natively, it uses the SpaceClaim file. which is a .scdoc or spaceclaim doc. Um, and those are all the files that I used here. I think it's a little more compatible, but spaceclaim is pretty powerful in that it can import uh, any. I mean, I don't think I've rarely come across a type of file that spaceclaim can't import, or Discovery Live for that matter. It's the same deal. Step files, STLs. Um, that is a tricky question. So I believe you can export a file from here to Workbench. However, uh, you can only get the geometry. You can't take any solutions or model setup. That's just the way it is right now. I think because the underlying way that it solves things is different, and in that if you noticed, you never actually saw a mesh in here. It's generated it on its own. It's doing it um, kind of intelligently, but uh, it's not compatible to take solution files yet, or setup files, just geometry, unfortunately. Yes, you are correct. Uh, yeah, the only option is to choose the speed versus fidelity, and um, to a power user that doesn't give you as much control. Um, and I know honestly that uh, being somebody who likes to have control over everything, it can frustrate me at a time. However, if what you're doing is trying to choose between initial design, um, uh, kinds of designs, or changing just a particular piece of geometry while you're still early on in the product cycle, um, this is very appropriate for that. Um, yeah, I mean, or just seeing how even as a power user, uh, I can see a use for just getting a first run at something. I know that when I import in here, import something in here, it'll solve really quick. If I want to make a comparison later to a finer solution where I have more control over it, um, it'll give me a first pass, and I'll be able to make that comparison. Exactly. Yeah. Good substitute for back of the envelope. And sometimes I guess it's handy in the sense that you don't need an envelope, or sometimes you just can't factor in everything uh, um, in an intuitive way to get those back of the envelope calcs. Um, so I'll leave this open for just another minute if you guys have any more questions. Like I said, if you think of something later, feel free to email Boz, or you can email me too. My email is dkramer at mallet.com. Yeah, no problem. It's really an impressive tool. You, have, you haven't seen anything like it in simulation before. All right, with that, I think I'll stop the recording. And like I said, feel free to reach out if you have any more questions later. Oh, there are trial versions. If you want to ask about the price, you should ask Boz, uh, since he's more knowledgeable about that than I am. Um, and yeah, he'll have access to trial versions to give you, but they're definitely out there and available. I do know, however, that it is much cheaper than a mechanical license. Uh, but Boz will have the specifics. Exactly. Yeah, I think that's the target market. Um, yeah, anybody who's a designer or um, even I, even management users can uh, take a look at this and get an idea of how something will perform in um, a rough way. Okay. I think with that, I will uh, say goodbye to everybody. Thanks for attending the webinar. Um, feel free to contact Boz or I. Again, that's D Kramer, Kramer, at mallet.com. And if you have any more questions or want a recording of this webinar, ANSYS has some good material out there for this as well. If you're interested in a very specific question, um, and yeah. So thanks everybody, and have a good rest of your Friday.